Hello, good morning all. This is an project CreateAIImage images which I have developed with the use of deep learning. So I will go through the projects and this readme. I have created a much better understandable readme. So in this project we have created five basic models. First is DCGAN trained on the MNSIT dataset for generating the images. Second one is I have used pitch to x, and via this we have created satellite to map transformation. And the third is restoration of old photos. If you have an older photo, then you can restore it by using GFP-GAN, and then use BoundLess for predicting some portion of the images. And then there is an image caption generator. I have built this by using CNN and LSTM. So I will go through all of these model and also show the results parallelly. So there's the basic introduction of this. Technology used here are Python, TensorFlow, basic keras, and CUDA. Also with Google Colab. So first one is DCGAN on the MNSI datasets. So it's a deep computation then implemented on handwritten digits. So by this we are generating handwritten digits. First I'm showing you the results. So let's see here, 2 is generated, 8 is generated, 6 is generated, 0740289 as you can see. And here is another similar generation, 7146873. You can see all of these are generated images, just handwritten digits. So here what we do is there are two basic things in every GAN. One is the generator, second is the distributor. The task of generator is to generate as realistic images as possible, and task of distributor is to distribute that, like distribute a fake image, generate a fake image, or like give it to the fake, like uh, discriminate between the real image and the fake image. If discriminate, we have to train discriminator such that it should know that this image is generated or this image is the real original image created by someone's handwritten digit. So you have to train both generator and discriminator. So we have made a discriminator and generator as you can see here, and then we give the random noise to the generator, and the generator generates an handwritten image which is not the actual image but a generated image. And then discriminator is trained very beautifully that it can discriminate and say that hey, it's a generated image, not a real image. So we have to do this, and the final when we train this on several reports, we get a result where the generator is, and then it gives a distinct gives a feedback to this that's a generated image, it's not a real image. So generator keeps on improving. So finally it gives a result such that discriminator is not able to discriminate. So this is the basic intuition of GAN also, which is applicable in all the GANs. So via this, something like this two sets are generated. Initially some random noise is generated. I will show you like this. Initial GAN output is this when epochs are very less, but it keeps on improving as when discriminator discriminates and say, hey, it's generated, it's not a real image, it's a generated image. So generator keeps on improving, like improving its weights. So yeah, this was a basic thing. And then we implemented bits to bits architecture. It's a conditional GAN basis of the unit. Here there are original image and it's corresponding a real truth, like a kind of changed image, you can say. Like I am showing with the example here, it's an input image and it's corresponding another real image is also a like satellite image to the map image can do. So what will be given if we have given a new satellite image, then we should be able to convert it to the new map image. That's the basic task, and this is the conditional then pitch to pitch, which will do this. So how this works is it should first thing is it should have a paired images, like two paired of images, input image and its corresponding a kind of real image only, and we will generate via some new input image fake generated images. So you can see the results of this input image, real image, input image. In these have used three things. Let's say ground is there, then ground and real generated image is also pretty good only in this. And when there are cities and road and houses, it's predicting pretty cooler, like it's predicting road. And when there is some water body or land, then it's predicting percent fine. And I'm showing this like it was at about 1K, and this is at about 39K. So as you Keep doing more reports and reports, discriminates, and they will put to the generator, and generator keeps on improving, and discriminator also keeps on improving. So via this, at much higher reports, we are able to generate pretty similar result, as you can see. And the third is GFP-GAN, which we have not implemented. We have used a pre-trained model from someone's GitHub repo. We have implemented these two above, DCGAN and pitch-to-pitch, but we have not implemented this GFP-GAN. We have used pre-trained. But here are some fascinating and interesting results. You can see this face is converted to this face to this face, this face to this face. This is pretty amazing. Results are there. You can see it works on multiple faces and all of the things. It breaks down into, like, it detects faces first and the background, then it improves the faces and background parallelly. So I've shown you only faces. You can read this how this works. And then there is a boundless image, which I already told you. There is an original image, but if you cut it, it has to predict the remaining image. Like, if say there are mountain ranges, if you show it a photo of some part of the mountain ranges, it will predict its left and right, some kind of that. So if this was the original image and we have masked this, we have removed the 30% of the right portion of this, then this our model predicted this. It predicted pretty well, like clouds also predicted a tree, which is slightly of different color, but okay, predicted grass, predicted everything pretty up to 60-70% accuracy. And this is a sunrise image with mountains, which is being masked, like half of the flower was removed. So it is predicted pretty well. It's predicted the skies and may fail to predict the green ground, but yeah, it predicted some grass kind of things. And this is another where also there is a sunrise is there. Here also we have masked and it predicted the prediction is pretty good. Here you can also see here it predicted these dialing also in the below bottom of the corner. Then there is an image caption generator. This is I have used CNN and LSTM for doing this. We have not used anything pre-trained here. We have generated model trained it on our own. Here I have used a data set which has the translation from image to multiple captions. 5 to 6 captions were there available on Tether. I use that for. Then I have detected the features of images using CNN VGG pre-trained VGG, and then used LSTM to arrange the words in the sequence. So I'm showing the results to you. So this is the result. Just ignore the start sequence and end sequence because it was a string. Man wearing black hat and glasses looking to the camera. Looking to the camera is correct, but it predicted this hair as black hatted. That's okay. That's the VGG's model for. Man in black sweater is smiling. That's pretty accurate. Two women are standing in front of a brick wall. The CNN predicted these as a woman, but this is a man. But they are standing in front of a wall, and there are two in number also. So up to 60, I will say 60% accurate results are there. You can say two children are sparring with their mouths stretched. There are three, but their arms are outside, and the garden are also there. You can see two kids are sitting on red car during an orange touch. This result is pretty bad, but it's also that red car is there, two children are there. See, two women are standing in field where there is one woman, one man, but field is right and everything is right. And also, one thing to mention is sequence is also correct. Like it's not a woman field, it's not something like that. And there's also there are sequences that are two kids. It's not like two kids sitting in the red car during orange. The sequence of words is pretty right. It is due to LSTM. Yeah, that's it for this. Thank you.